we present BlendFace, redesigning identity encoders for face swapping. Face swapping aims to replace a target identity with a source identity while preserving target attributes such as face expression, head pose, hairstyle, and background. With great previous works, we can swap countless faces for various pairs of source and target images without individual optimization. However, existing face swapping models sometimes transfer source attributes into swapped results, as shown in the figure. We call this problem attribute leakage. In this work, we identify that this problem is caused by face recognition models that are used in face swapping models as identity encoders. We present a novel identity encoder BlendFace to address this problem and achieve more consistent face swapping. Most existing face swapping models consist of a generator and an identity encoder. ArcFace is a state-of-the-art face recognition model that is widely used in face swapping models as the identity encoder. In the training phase of face swapping models, the identity encoder extracts identity features from source inputs for identity conditions of face swapping. The identity encoder also encodes swap results for identity loss. We found that such face recognition models recognize attributes as identity, which leads inconsistent face swapping. We examine the identity similarity between an anchor and positive, negative, and swap face generated by simple image blending on positive and negative, as shown in the left figure. After iterating this process for various quadruplets, we visualized identity similarity distributions in the right figure. We observed that the similarity for swapped is lower than for positive despite the same face. This indicates that face recognition models tend to encode outer face information such as hairstyle, which makes swap faces excessively similar with source faces. To address this problem, we propose a novel identity encoder, called BlendFace, specialized for face swapping. We train ArcFace to classify swap faces into the same class with positive, so that the model does not recognize face attributes. After the pre-training of BlendFace, the similarity distribution of swapped is much closer to that of positive while keeping the discriminability for negative samples. Then, we replace ArcFace encoder with our BlendFace to train better disentangled face swapping models. Here, we compare BlendFace with ArcFace. We use AINet for the base face swapping model. We can see that ArcFace accidentally transfers source attributes such as hairstyle and head shape into swap faces, while our BlendFace achieves consistent face swapping. We also compare our method with previous state-of-the-art face swapping models that depend on ArcFace. In the cases where source attributes and target ones are much different, previous models suffer from the attribute leakage problem, while our method consistently generates promising swap faces. In conclusion, we find face recognition models such as ArcFace used in face swapping models have an attribute bias, resulting in inconsistent swapping. We solve this problem by training a face recognition model with swapped images to mitigate the bias. Our model performs high-fidelity face swapping compared to ArcFace-based models. The coded models are available at GitHub. Thank you for your attention.